So, good day. Today I'm going to explain to you our task for week 5. My group mates are Eric John Habal, Joseph Foronda, and me, Carlos Dwayne El Soralio. So, for the task, uh, we are to be made by a 7-segment code with input switches. We decided to have 1, 2, 3, 4, 5, 6, 7, 8, 9 input switches with our names in it. So for A to be decoded, it has a binary value of 000, E 001, I 010, O 011, and U 100. If it is non-vowel, the binary code will be 111 and the decoded value is C. So let us see that. This one. So for the encoder part, I will discuss about how I come up with this encoder part. Eric will discuss the decoder, and Joseph will simulate the circuit. So here I have 3 OR gates with 6 inputs, 7 inputs, and 7 inputs. And this is our switches, Rick, Carl, Seth. So let's discuss how I come up with this circuit, the encoder circuit. This one. So this is the input and this is the output, XYZ. And I made the input have a value of 1 in the diagonals, as you can see here. Then the output will adjust accordingly. So if F is a non-vowel, so it has a value in the output XYZ 111, E as the condition stated 01001, non-vowel 111, and so on and so forth. A has a value of 000. So after I made this, I created the logic circuit for XYZ. I mean logic function. So this is X is equal to F plus S plus L plus R plus C plus R. So how did I come up with this? If F is 1, as you can see here, F is the only value that has a 1. So and X is 1. So since this is SOP, so we will put F here in the logic function, as well as S, as well as L, R, so on and so forth. The same with Y. If Y is 1, so it will take the value in the input that has a value of 1 also. Then, after this, I created the circuit according to this logic function. And this is the circuit of the encoder part. So next will be the decoder part, which will Eric will explain. Thank you.
So what is up, guys? I am Eric John Havel, and I am here to talk about the decoder part of our logic circuit. So here we have our circuit, Ricardo, and here we have the decoder, which decodes the encoded codes so that the output is shown properly. So here we have our decoder part. So we obtained this circuit through the use of K-map so that we can simplify the circuit. So here we have our truth table for the decoder. Here we assigned a number for the segments for the output, LED output. So here we have there. And since we have these equivalents of vowels, A, E, I, O, U, and non-vowel, which we output to C, we assign that. So 1, we only have 0 at F at number 6, since A, you can see the shape is composed of 1, 2, 3, 4, 5, 7 segments. And for E, we did not use the and G, which are 4 and 7 segments, so that the 3, 2, 1, 5, 6 segments are used. The I 4 and 7 only. O, the 1 is not used, and U, 3 and 1 are not used. And since we do not have any outputs regarding the 101 and 110, we assign that as X, and non-vowel as C. So C is not composed of 1, 4, and 7, so those are 0. And we obtain this truth table, we get the K-map of A of each letter segment. So we have that, and that, and that, and that for A, B, C, D, and E, F, G. So since we have this K-map here, we simplify the circuit to be A not B not, A not B not, yes, B not, that is A. And B is B not plus C. For C, we have A not at B not plus C. For D, we have A not B plus C naught. For E, we have B naught plus C. You can see here. And F, we have simply A plus C. And G, we have A naught B plus C naught. So that is our decoder part. And the next one is Joseph, who will be discussing the demonstration simulation. That is all.
Okay, so simulating the circuit, pressing the consonant F would yield the binary 111, which means it would be a constant at C. Pressing E would mean it is coded as 001, a vowel which is decoded as E. S would is since it is also a consonant, it would also be decoded as 111 and decoded as C. L is a consonant, so it's still C. R is still C. A is a vowel, so it would encode it as 000, producing A. C is a consonant, so it's encoded as 111 and decoded as C. I is a vowel, encoded as 010 and decoded as I. And R, which is also a consonant, would be encoded as 111 and decoded as C.